going to sort of jump right into it. But this, for me, this is, and I suspect for all of us, this is pretty exciting to be able to connect these different spots around the world and to be able to see people and share information. Well, this is really what the promise of the internet is, and we're very glad to be able to try and do some of these things. And I did want to welcome everybody and thank you very much for making the effort to participate. I know we've done lots of trials and tests, and it sometimes works well and sometimes it doesn't. But the fact that we're all online today is pretty exciting. This is our agenda. I'm going to try and be very brief so we can get right into Trevor's presentation, and then Eduardo is going to present from Monterrey, and then the people at the Cardiff School are going to present. We're still hoping that Daniel might be able to join us, but as I mentioned, the University of Witwatersrand is been more or less locked because of protests. Our thoughts are with them today. Then Kristen is going to talk a little bit about the Trello software as well, and then there'll be some time for discussions and questions, and then a reminder about the next meeting. So, does anybody have any questions about the agenda? Okay. One thing that'll help, especially if you're in a room full of people, is if you're not presenting or asking questions, you might want to mute the microphone on your phone. We do. One of the reasons that we use the audio is much clearer than anything we can get through video conferencing, and that's just a quick reminder. I'm going to, there I am, I'm doing the overview, but I would like to have a quick chance, maybe very, very quickly, if we could if everybody just checks in, just says really briefly who they are. And so I'm going to start up in the top there with Emma, just to say who they are, and we'll try and do this very quickly because I know there's a lot of people.
Hi, everyone. Thanks for joining today. My name is Emma, and I am the student advisor for the Bachelor of Science in Architecture program with Athabasca University.
And it's the Cardiff people.
John Council from Cardiff Metropolitan University. I'm an architect by background.
Hi, I'm Nick Evans, also from Cardiff Met, and our other colleague John Littlewood is at the back there. We also have some very keen level 5 and level 6 students here as well. Pleased to be joining you.
Wonderful. Kristen?
I'm Kristen Kornienko. I'm an academic expert at Athabasca University, and I'm also a visiting research fellow at Wits University in Johannesburg.
And Eduardo.
Hi, my name is Eduardo Torres. I am from Tecnológico de Monterrey on the Masters of Energy Management.
And Marco.
Marco Rodriguez from the Tecnológico of Monterrey. I'm a student of the Master of Energy Administration and Renewable Energy.
And Trevor. Trevor?
Sorry, I was on mute. Trevor Butler, engineer, trying to work out how phones work.
And Karim?
Karim Abugaber, mechanical engineer from Tecnológico Monterrey, doing the master like Marco. I'm living in Dar es Salaam, Tanzania.
And Liliana?
Hi, I'm Liliana from Baja California. I am a student from Tecnológico Monterrey, doing the Masters in Energy Management.
Okay. And now I'll move to the people who are on the phone line. Bobby?
Can you hear me? I'm not sure if I muted my phone.
You're perfectly clear.
Okay. My name is Bobby Harris. I'm a AU syllabus student and student representative here in Edmonton, Alberta, Canada.
And Karibay?
Karibay doesn't.
Karibay has troubles because she doesn't have, right now, she doesn't have access to a phone line. So she said she was just going to log in to the Adobe Connect, but she's not going to be able to do the conference.
I understand. Thank you very much. So we'll try and work that out for next time. Christopher.
Oh, hi. I'm Christopher Story. I'm an AU syllabus student in Calgary, Alberta.
Excellent. And Courtney.
Hi, I'm Courtney Bruins. I'm an AU student from Medicine Hat, Alberta, Canada.
Now, I noticed that Daniel is there in the list. Daniel, are you online with us?
Just sent an email saying he's having trouble, so I've just resent him the phone number and the passcode. So hopefully we'll have him in a few minutes.
Okay. And Felipe?
Felipe Carvalho. I'm out of Edmonton. I'm doing the Bachelor of Architecture and Science.
And Fernando?
Fernando Martel is our teacher of the project optimization course here at Dial, yes.
Wonderful, thank you. And Mateus?
Hi, I'm Mateus from Calgary. I'm in Athabasca University, also taking a Bachelor in Architecture.
Okay, and then I think Victor, are you with us?
Yeah, sure. It's Victor Salazar from Mexico. I am student of the Energy Management master's degree.
Wonderful. This is great. Hopefully we'll get Daniel online in just a few minutes, but in the meantime, we'll sort of keep on going. I'm actually, just in case I didn't introduce myself, I'm Douglas McLeod, the chair of the REIC Center for Architecture at Athabasca University. And I just wanted to remind us while we're here today, we really are talking about sharing and allowing students to refine their ideas in terms of passive design, mechanical systems, and building envelopes. And we do want to develop a shared set of online resources suitable for sustainable building science. But also, we have tremendous experts in the field with us today, and it's going to be great to hear what they have to say. Over time, of course, bigger than this project is building an international community of practice so that we can share information and start to work together to solve this, what is really a critical problem. And with that, Trevor, if you're ready to go, let's let you get going, because I know you have a meeting with royalty.
Thank you. Good morning. Good afternoon. Good evening. Can everybody hear and see the screen okay?
Mm-hmm. Yep.
Yeah. Okay. So I'm going to spend about 15 minutes just going through this Matchbox Energy software, and everybody on the course, on this program, will have access to this tool, and I hope that you've all had a chance to log in and familiarize yourself. I have an example that I'm going to go through very quickly, and you'll see how that works. I'd like to thank Bobby for sending through his drawings for this new building in Edmonton, and this is it's like a indoor riding center, and I'm not going to use this as an example, Bobby, but it would be. I only got it kind of yesterday, and I haven't had time to really get it into a format. But really, you can use Matchbox for any kind of building, whether it's an office or a library or a museum or an art gallery or housing, whatever your project is. You will be able to use this software for. And so I guess every student and every faculty has a different project plan for your design. And so with that, I'm just going to go briefly through the Matchbox example. These are the things which you really need. You need the size. We need to know where the building is, how it's oriented on the site, how many people are in there, what kind of internal loads are present, like lighting and plug and process loads. How well insulated is the building? What is the specification? And how leaky is it? With these things, we can enter the physical parameters of the building and end up with a energy calculation and a carbon footprint. So the example I'm going to use is a very basic 10 meter by 10 meter box, a 2-story house with a flat roof and different areas of glazing on different elevation. So it's, for the purpose of this example, it's perfectly orientated north, south, east and west, and that will be much easier when we come to do the inputs, but you will see that it's possible to do flexible orientations as well. So this is where we start at this page. You will have your own login email address. I hope you've all registered. And then every time you come back to the screen, you just log in with your details, and you can then start to use the tool. Oops, something went wrong. Okay. That's not a good start. Half a second. There we go. I do expect there'll probably be a couple of glitches that you may find. If you do, just go back and re-log in like that. Okay, so we're going to start with a building in. We could start a building in. Which country do you think we should start with? I'm going to say we're going to start in South Africa in honor of Daniel and Joseph, and we're going to choose. I think we're going to choose Johannesburg. Our building has one zone. It's just a single house.
Joining conference.
And
Daniel, just sorry to interrupt. Daniel, tremendous that you've been able to get online. What? I thought it was Daniel.
Okay, well, sorry. Welcome, and we're honouring South Africa today, and so the nearest city, we can choose whatever city that we like. We do have Dar es Salaam. We have a lot of Mexican cities. We have from Colombia, from UK, of course, from across Canada, across US, across other parts of Europe and Asia. So there's a real variety of countries in here. You can see the different countries that we have. So Botswana, Colombia, Denmark, Germany, Ireland, right through to Zambia, the US, Tanzania. And in here we have, whenever we select a country, let's go to the UK. You can see we have Cardiff. If we go to Mexico, we have Monterrey, Acapulco, Guadalajara, etc. And you'll see that the temperatures and the mean temperatures vary depending on what city we select, what country we select. And the yearly high and the yearly lows are the factors that will determine our heating and cooling loads of the building. And here we can see how the mean temperature based over 24 hours of the year varies like this. So we've selected Johannesburg, and now we're going to talk about the building itself. So it's a residential building, and we were able to decide how is this building used. So for an office building, we would generally say that it's only used on weekdays, but for a house, it's a week-long building occupancy. How many people in a small building of 10 by 10? Well, probably we're going to say maybe 4 people will live there. The floor area, this is where we enter in the total floor area. So when we come back to this building here, it's 10 by 10, which is 100 square meters, but we've got 2 floors. So that's 200 square meters is what we will enter for the total floor area. So you add up total floor area across all floors. The floor-to-floor height, we will say is 8 feet, which is about 2.6 meters. The hours per day that we're in there, generally in residential, we're in there for say 12 hours a day because we like to think we're active and out and about. But you can adjust this up and down as you wish. And there's no right or wrong answer there. It'll really depend on the type of building that you have. The internal temperature, this is what do we want to maintain as comfort levels. We can adjust this up and down. In the winter, we might want to be 23, but in the summer, perhaps 19. A good average is about 21. Then we need to look at, do we have heat recovery systems for ventilation? With things like passive house and very tight building envelopes, we have to provide heat recovery. And normally this is done through mechanical systems, and they have different efficiencies. So in hotter climates, we would probably want to have heat recovery during the summer or during the cooling season, as well as in the heating season. How much heat per person do we have? Well, this is to do with the metabolic rate of the people in the house, and the standard metabolic rate is 100 watts per person. Just sitting down, walking around inside a building is about 100 watts. And this is important to know because it will show how much cooling do we need to have. We do have a glossary over here which helps to explain what some of these things mean. So heat per person, or what is a heat recovery ventilator, what is HRV efficiency. We can just pick these up over here at the glossary and then go through just different assistance there. There is also a user guide which I'm basically going through right now, and you can see kind of step by step how we are going through that. Okay, the next thing we're going to say is how much airflow, how much outdoor air do we need to supply? And generally we supply this by a quantity of outdoor air for each occupant. And 10 litres a second of outdoor air is a good volume to provide, because it means we don't actually breathe 10 litres a second because our lungs aren't that big. But this deals with other things like build-up of CO2, odours, off-gassing from materials, and things, and machinery and equipment. So 10 litres is kind of a good, safe rate to put in for managing internal air quality. Then we need to enter the electrical kind of loading and the mechanical systems. So lighting loads are generally worked out in terms of watts per meter squared. And in a residential building, you can enter, say if we had an office, it would be more like 12 watts per square meter. If we had retail, like a store with a lot of lighting for products, it can be very high. Now you can adjust this up and down as a manual entry if you need to as well. If you say, what about art gallery, where is that? It's not on there, so you can just say, well, an art gallery is more like 30 or 17, whatever you want to put in there. Similarly for plug loads, this is to do with running electrical appliances like ovens and fridges and televisions, computers, phone charging, washing machines, etc. And you can enter in how many watts per square meter on average are there for plug loads. Then we get into selecting what is the heating system and what is the cooling system. So in a very hot climate, we would probably tick no heating. In a cold climate, we would definitely want to put some heat in there. So in Canada, we would be looking at different heating systems. And these can range from electric baseboard heaters to ground source heat pumps, gas boilers with central heating. And these affect the efficiency, which is called the coefficient of performance. On the cooling side, we in some buildings we don't have cooling because they're very well designed. There's good shading, there's good natural ventilation and materials, but we can also select any kind of system that we want. So I'm going to say that we have a split system which just provides cooling in the summer when we need it. And then with hot water, this is another significant energy user. And in a house or in an office, we work out how many kilowatt hours per person per day do we use for hot water. And I'm going to say that we're very good here, that although we are using a house, we're only going to say use 1 kilowatt hour per person because we have efficient water features. That's everything on the climatic internal environment, and now we're going to go through the external envelope. So the roof area, we're going to go back to our example. Our roof area is 10 by 10, so that equals 100 square meters. We have no roof lights, so 0 roof lights. If we have skylights or roof lights, we can enter in by a percentage here. But for our example, we have 0. We have a number of external walls. We can have as many as we like, but here we only have 4, and we go through each tab and we can enter in the different wall types. So wall number 1, we have to enter in the details. So on the north elevation, we have the section showed that we have 3.5 meters and 3.5 meters. And I'm just going to go back to the over here because our floor to floor was 3.5 and not 2.6. So on the north elevation, we can say, is the wall vertical or is it sloping? Sometimes architects like to do sloping walls, particularly Frank Gehry or Daniel Libeskind. They do kind of different slopes, but you can alter that. But for our example, we just have straight walls like this. And the orientation of the first wall is it's actually north facing. You'll see that the name of the wall changes up here depending on what orientation we take. We can also take, east-northeast or different variations. And this graphic changes as well as the description. So the area of this whole wall on the north elevation is it's 10 meters across and it's 7 meters high. So the elevation here, which I've highlighted, is 10 by 7, which is 70 square meters. So the area of that is 70. How much glass do we have? We have 6 by 1, and then we've got 2 windows at 2 by 1. And so therefore that equals 10 square meters of glass. And we need to enter in a percentage glass ratio. And that comes out at 14.3% glass.
Good morning, this is Melanie Campbell calling from the Christian School. I see that both Allegra and Charlotte have realized absent this morning.
Sorry about that. So then we have, we'll then go on the east elevation. And here again we have 10 by 7, which is a 70 square meters. And our ratio on these deals with heat transfer between the indoor and the outdoor environment. And our floor is either exposed to the ground or it's a cantilevered floor exposed to the air. Well, on our example, we're exposed to the ground. So we have 100 square meters exposed to the ground. You'll see that there were some elements here on shading, and this is where you can adjust the shading for different times of year, different elevations. So normally you would put shading on sort of south and west. I'm going to leave them all at 0 for now, but this is where you can play around with the building later on to see how you can make it more efficient. So that's really the physical form of the building now. The structure is all in place. And then the last tab that we need to go through is to do with the building specifications. How well insulated is the building envelope? So here we have an R value or a U value. Now in North America and in other parts of the world, there are metric units, but there are imperial units, and people tend to use R values rather than U values. And this is something which I found when I first moved to Canada, that it's very confusing. So I prefer to work in metric, but I convert R values to metric values so that we can be on an even playing field. Typically, the R values of walls in Canada is an R20, and so if you enter an R20, you can see here there's a calculation formula that tells me what the metric U value is. So an R20 wall is 0.28, an R25 wall is 0.2. You'll see that the higher R value gives the lower U value, and that's because they're inversely related. So if we start with an R20, which is kind of a normal code, this is the U value, and we can just copy that and paste it in there, or you could just type in 0.28. Now the glass itself, normally for a double glazed window, I'm not sure the latest U value in UK, but I would probably work to say a 1.8 U value, and that shows how well insulated the glass panel is. That's like a double glazed unit with a low E coating and some gas fill between the panes. This solar heat gain factor really describes how much solar heat is allowed through that window, and it affects how much overheating you could occur. What we can do, if all of the walls are the same on your building, you can save time just by clicking this box that says assign values to all walls. And it will say to all walls in this zone, and we say set. Then we can look at wall east, and south and west, and see that the insulation and the glass is all the same. The final bit we have to deal with here is the infiltration. How much air leakage comes in as a result of gaps around window frames, walls and floors, roofs and walls, etc. And on a very well insulated building, this should be a low figure. It's hard to work out exactly what it is. So there's a little guide here. If you click this question mark, it will give you some ideas based on a tight building, a regular building, and a leaky building. So for a single family house that we have with 100 square meters and a 6 meter height, the air change rate could be about 0.15 if we were doing like a passive house standard. If we are doing a regular code or an older building, you can see how the volumes change. So over here, I'm going to enter in 0.015. That means 15% of that building air volume will leak every hour as a result of infiltration. Then we need to put in the U values for the floor, and I'm going to say that the floor has a 15 R value, and that gives me 0.3786. Put that in there. But this is for a floor that is exposed to the air, for a cantilevered floor, so we can actually delete that. We do not have that example, but we have a floor that is cast onto the ground with insulation. The roof itself, a lot of roofs are moving to be around an R35, and that gives us 0.16 for a roof. We put that in there. We have no roof lights or skylights, and therefore there's no heat gain coefficient. If we had several zones of a building, we could just select this, but because we have one zone, we do not need to do that. So now that's the model, all input. That's all that the input you would have to do for your project. If we had a building, say with an apartment building in a city centre, we could have retail units on the ground floor and then some apartments or flats above it. And that would be a two-zone building. So we would set one as a residential zone and one as a commercial zone. And we'd build those into the same model by over here when we would select the number of zones. And that would then follow through. But now we've input a whole building for this example, with the glazing, with the elevations, with the roof and the floor, and the internal systems. We're ready to see how we will perform. So there are two ways of calculating here. Now I prefer to use this panel here and to use on the output pane to provide inputs and results on the same page. That means you can go back in over here and make changes, and then calculate the results and see what difference you get. The results are split between net energy use, gross energy use, peak loads, solar gains, fabric loads, which are to do with the envelope, how much heat or cooling comes through the building skin, ventilation load, to do with the outdoor air, and casual gains from people, lighting, and plug loads. This is the moment of truth. You click calculate results. Oh no! Oh dear! And we've got an error here. And I don't know what's causing that. So let me just go back over here. All right. What could be the problem? Let me look over here. I think what I'm going to do, and residential.
Trevor, it's Nick Evans here in Cardiff Met. This was the problem I had when I was testing the software, and I found if you say to in, logged out, logged back in again, so it automatically opens the last project that it calculate.
Yeah, that was good, was it?
That's how it worked for me. So I don't know whether that's worth trying it.
Okay. Yeah, otherwise I'm going to have to ring my support line and see what it does. I might do that. It's just saving. Let's just let that bar finish working. There are the main thing that we really focus on. These certainly from our perspective of demonstrating compliance with code for building regs is that we look at the EUI, the energy use intensity, and it's hard to say, is this good or bad, particularly for projects around the world in different parts of the world. So I've tried to just give some indications here, really, and this is for discussion. This is not like the answer to everything here, but there are again 3 standards of kind of a sustainable building, what I call a green building, and a code building. And there's 3 kind of typical climate zones, like a heating dominant zone, or a cooling dominant zone, or a moderate zone. We can see how that would come up for offices, residential, retail, or education. Okay, let's see if that's done anything yet. I think I'm just going to log out then and try and come back in. Okay, on-site building. Right. I don't know what the problem is, folks. I'm sorry. I'm going to have to just have a word with Jake and see if we can fix this. Can we? Let's just leave it here for now. I'm sorry about that. I'm very sorry. It seems to be something in the project there. So I don't think I can resolve it straight away, Douglas. I said there'd probably be a couple of errors here, and I wasn't expecting this.
Okay. What we'll do is we'll let Trevor work with the support people in order to get this all functional for everybody. It is very extensive, though, and I think it'll be a very valuable tool. I mean, the fact that Trevor and Richard Croker are letting everybody use this for the life of the project is very, very generous of them, and we did want to thank you, Trevor. So maybe you could post to the group once everything is fully functional again, and we can let everybody use it. But I do appreciate all the work that you've done on this. I will just let people quickly ask a few questions before we get on to Eduardo's presentation. Does anybody have any quick questions for Trevor?
No.
Okay. As I say, this is very actually, as I say, it's got a lot of complexity to it and a lot of really interesting aspects to it. So I think this could be very useful for people. But at this point, I think we will keep moving along. But Trevor, thank you very much for joining us this morning.
I'll be in touch soon. Thanks.
Okay, thank you. And the next presenter is Eduardo Francisco Torres Puente from Monterrey. And Eduardo, and this goes for every presenter, I don't really know everybody, so I'm going to let everybody introduce themselves. But I want you to have a full 15 minutes, so I'll hand it over to you.
Hi, thank you, Douglas. Yes, my name is Eduardo Torres. As I told you, I am a teacher here at Tecnológico de Monterrey on the Masters of Energy Management program. You please continue with the next slide, please.
I gave you presenter, so if you just use the arrows in the bottom left-hand corner, you will be able to do it.
Okay, so I can share my presentation. Thank you.
Well, your presentation, we've uploaded it for you, so if you just use the arrows in the bottom left corner.
Oh, thank you.
Yes, there's just...
There you go.
There we are. Excellent.
Oh, sorry. I'm not familiar with this system. So this is our first meeting of the Sustainable Building Science Virtual Studio. Our teaching team is Fernando Martel Chavez, PhD. He's actually here, but he's having trouble dialing to the teleconference line. And myself, Eduardo Torres. We are, just to mention, most of you, or practically all of you, have an architecture background. We are electrical engineers, actually electronic engineers, so we are more focused toward the electric efficiency use of these technologies, of this building software. So I will give you a small background on our master's program. Also, I'll mention some of the programs that are related to sustainable building science, and I will present the two projects we have on the workshop. As I mentioned, I am currently part of the Master in Energy Management and Renewable Sources. It's an online program at Tecnológico de Monterrey. Actually, I think just one of our students of this workshop is in Monterrey. Some of our Mexico City, Querétaro, Ensenada, and we have a student in Africa also, which is Karim. The objectives of our program are to educate professionals in energy optimization for private and public sectors, and to develop skilled professionals in energy management, including the use of conventional and renewable sources. We are more focused on energy management. Not we do have architects as students, but we are mainly focused on energy management, on electrical engineering, thermal energy also. So we have which courses on our program are related to sustainable building science. We actually have an energy management in buildings, which the professors are Sergio Melendez, which is an architect, and also Susana Martinez, which is also an architect. And we also, the course that we are currently participating in the workshop is the Energy Optimization Project, which is led by Dr. Fernando Martel and myself, Eduardo Torres. I will now present the two projects we have. We're actually, the project was originally focused on low-income housing. We are now focusing on medium-income housing. Here in Mexico, there is a lot of housing development lately, mainly because the government wants to give people a place to live, and they usually give low-income housing and medium-income housing. This team is focusing on the design optimization on northern Mexico, the idea is that they do a simulation for Ensenada towards a net zero energy consumption through the assessment of the following variables: the envelope, mainly the material of the house, the orientation. They will also assess the lighting systems, the HVAC systems, the house appliances and loads, and will also apply photovoltaic systems to generate energy on site. This is, as I mentioned, the location is in Ensenada, Baja California. This is more or less the area of a medium-income house, approximately 150 square meters, with a dining room, living room, a kitchen, 3 bedrooms and 3 bathrooms. And that's approximately the composition of the house. This is an example. The students originally were focused on a low income. These pictures are more of a low income house, about 40 square meters house. This is basically a medium income house would be something similar like this, but with a second floor. The team, project number 1 team is the students are Cariba Godoy Rangel, Jorge Luis Pedrosa Rivera, and Liliana Salgado Perdomo, which I think most of them are here with us today. Now I will go with project number 2. Since we are not focusing on house design or building design, usually our projects are more of applying certain strategies for saving energy or certain technologies. In this project number 2, they will do an energy analysis of the HVAC system in an apartment in Dar es Salaam, Dream Glory Apartments, and they will mainly focus on doing a comparison between standard windows and energy efficient windows. As I mentioned, the location is in Dar es Salaam, Tanzania. The window area is approximately 10 square meters, and the AC system is composed by 4 units, 2 1-ton units and 2 1.5-ton units mainly. And these are pictures of the windows. And the team is composed by Karim Abugaber Falcón, Marco Vinicio Rodríguez Herrera, and Víctor Salazar Saavedra. As I mentioned, usually our projects in this project are mainly focused on energy strategies more than building design. We wanted to integrate this workshop on our energy management for buildings course, but it was not. This course will be given in the next period, so we just integrated here for our project optimization course. And these are the 2 teams that will be participating. I think I was a little fast. I don't know if there are any questions for the project. Here in Mexico, we are mainly focused on air conditioning systems. We do not use heating that much, at least on northern Mexico. It depends on the zone, but we usually, at least here in Monterrey, we are mainly focused on air conditioning systems, and we usually have some electric heating when it is needed, but it is not like in Canada, for example, which I think that you have really extended need for heating systems. Thank you, and I don't know if you have any questions.
Yes, thank you very much, Eduardo. Those projects look really interesting, and I think actually they look like they would work well with Trevor's Matchbox software as well. But are there questions for Eduardo? Okay. But thank you very much for that. And again, I'm very interested in how the projects are sort of right around the world, and we'll look forward to working with everybody on those ones.
Okay. Thank you.
Thank you. I think we'll move on to Cardiff then, and again, I'll hand it over to Nick and John.
Hi there. I hope you can hear me loud and clear. I'll kick off the presentation just talking about some of the things which we're doing on our undergraduate program. Perhaps actually before I do that, a little bit of description about who we are. We're Cardiff Metropolitan University. We are here in the capital of Wales, Cardiff, city of about 300,000. I suspect many of you perhaps won't have heard of it, but that's our city. maybe more sunny than it normally does. Okay, and this is a bit of information there about Cardiff. We are Cardiff School of Art and Design, one of the schools in the university. Around about 12,000 students, and around about 5,000 students are international students. Not a huge university, but there's an awful lot going on here. The program which I'm actually involved in is the Architectural Design and Technology. We're not a school of architecture. We are an accredited course by the Chartered Institute of Architectural Technologists. And what the teams of students will be working on will be predominantly office buildings which are situated site to the north of Cardiff for high-tech media companies. So it's quite an exciting opportunity to do some optimization of those designs using the Matchbox software. I'll just quickly run through sorts of building science things we do at undergraduate level, including fire as part of our building science. We do an awful lot on building regulations and in relation to fire safety, means of escape in case of fire, and so on. So if there some of my slides, I always go on about building regulations, I'm afraid. HVAC, we're not engineers, so we deal with this, as I suppose many architectural schools do, in the context of having to understand the importance of integrating these into the building, although we don't do complex calculations on ventilation. But you can see we deal with natural ventilation, forced ventilation, air conditioning, and a whole range of other techniques as well in terms of heating, ventilating, and so forth. We're interested in renewables. I don't know why the S has fallen off. Oh, there it is underneath. We're interested in renewables, we look at wind power, solar power, PV, and so on. We do some calculations with these, calculating outputs of PV panels, for example, looking at how we can optimize our buildings to make best use of what little sunshine we actually get here in Wales. Energy rating. There is a requirement for new buildings in the UK to have energy ratings which are produced and published, and so we have software which calculates energy ratings for us. So last year we used a piece of software which I think is on the next slide. There it is. SBEM. It's one of the government's recommended calculation methods. It's an extremely cumbersome piece of kit to use. It's slow, but it is very accurate. We are very much looking forward to using Matchbox like a much more user-friendly way of getting what is essentially information. And so our students through SBEM last year, I'm sure they're going to grow to love Matchbox. Environmental impact, that's involved in looking at selecting materials which have minimal environmental impact. We have a methodology which is substantially in the UK, based around the Green Guide to Specification. Some of you may be familiar with it. It's a technique for calculating the environmental impact of building materials. So it gives us a quantified method of looking at environmental impact. It's not without its faults and detractors, but it's a very useful system nevertheless. You may be familiar with BREEAM. BREEAM is the UK version, if you like, of LEED, which is perhaps more widely known in the Americas and further afield. And it's a process for looking at the overall environmental impact and sustainability of not just new buildings, but refurbishments as well. So we don't do a lot on BREEAM. It's quite specialised, but our students are introduced to BREEAM. So quite a lot of stuff which we do look at. So that's just some BREEAM ratings. It gives a percentage which can then be turned into a rating such as very good or excellent or outstanding if you're getting very sustainable buildings. We also do a bit on passive solar design. So again, we're hoping by using the Matchbox software, taking these office buildings to the north of Cardiff, and that we can optimize their passive solar attributes. What I want to do is I want to pass on to my colleagues, John Council and John Littlewood, who are more heavily involved in research and consultancy than I am. And there's just a few slides which I they'll want to comment on here.
Okay, John Council. We've been recently doing a project with the Heritage Organisation, the Government Heritage Organisation in Wales. More than a third of the housing and other properties in Wales date from pre-1919, but generically be described as heritage, and they're part of the landscape, part of the situation that attracts tourists in. So it's important to understand how better to bring them up to date without destroying and rebuilding them. And so on this particular project, it's been it's 1860 dated miner's cottage, coal mining. Yes, measuring it in every way over the last 2. So we used thermography, laser scanning, and also had it festooned with sensors throughout. And the idea is eventually to optimize it and then to have it occupied and to keep measuring it. This is another project we did recently with the local practice of architects with national funding, and we were looking at how we could construct breathable internal wall insulation and, in a very similar situation, start to optimize a traditional building structure.
Neil, there.
Yes.
Okay, so just to extend what John Council was talking about, the research group we've got, Ecological Built Environment, focuses on a number of different areas, and one of the large areas we work in is building performance evaluation, post-occupancy evaluation of buildings, mainly domestic buildings, single two-storey houses to multi-storey buildings with apartments. And we're all, as part of this, we're looking at the fabric design, the construction quality, and post-occupancy energy use and thermal comfort. What's been driving this very much has been something called the performance gap in the UK, where we design low zero carbon buildings. We're supposed to construct zero carbon buildings, but in actual fact, some of these buildings aren't constructed correctly, and often the users and occupants suffer. See something called the performance gap. So we're engaged in a range of techniques, from thermography to air permeability testing and smoke testing as well. And as part of the post-occupancy evaluation work, I've just got a graph here from one of the projects we finished in 2015. As part of a UK national monitoring project called Building Performance Evaluation, and this is just showing one of the temperature graphs from one of the houses where it was supposed to have comfortable internal temperatures, and in fact it didn't have comfortable internal temperatures. It didn't actually overheat, but very often it below 19 degrees, the minimum temperature for comfort in these houses, and these were supposed to be low carbon dwellings. And moving on finally then to some work that we started in 2013. I've predominantly worked in thermal performance, and that's how I got to know Trevor Butler in 1998. In 2013, as part of some of our smoke testing air leakage rates, we discovered that our smoke, our dry ice, was passing between compartment walls, floors and ceilings. And now, working with the fire brigade and various housing developers, we found a weakness in compartmentation in the UK, and not just in houses, it's affecting schools, all sorts of buildings. And we're developing a tech where we can go into buildings as part of fire risk assessment, working with housing developers and the fire service to help identify where there are problems. And working with John as well, John's been identifying low-cost sensors measuring particulate matter, which we're also going to use. You can see one of my research assistants here showing one of our prototype test rigs, and the sensor is the air sensor is at the bottom, and we're hoping to use that in the forthcoming weeks. And finally, this is the last slide. I mean, most of our research is actually almost like consultancy. We're working with outside companies who come to us with a problem, and we find a problem and go find a company to work with. Started with off-site manufacturing with a local, quite a 20-year-old company that specialises in what they think is innovative prefabricated construction, not innovative. So we've been taking them around the UK to showcase what can be done by using Scottish timber, and we're trying to bring the learning back to Wales. So that's the last slide we've got there.
That's the last one. Yeah. Great. Thank you very much for listening, everyone.
Thank you, Nick and John. Everybody's keeping very good job of keeping within their time limits. So we do have time for questions. Are there any questions for the people at Cardiff? It looks like now Bobby has raised his hand. So Bobby, do you want to have a question?
Yeah, I'm just playing around with the system as well. Where do you, after you've collected all this data and it's sort of sitting somewhere, who gets it? Like, are you passing it along to just the people that are paying you for research? Or are you getting it out to the public, saying, hey, you can do this? Just kind of curious, what do you do with that information that you're collecting?
The data from the UK National Building Performance Evaluation Programme, which was a £8 million programme, is publicly available. We had to submit a final report, and all the data was submitted to Innovate UK and is publicly available. Something called Digital Capital Buildings. It's been made available from 2016. Afterwards, if you send me an email, or Trevor or Doug, I can send you all the data. Other data we're publishing, the fire performance data is quite sensitive, so we're working with the Fire Service. Having said that, I've just been to Turin to present on that data, and I'm presenting to the UK Chief Fire Officers Association in November this year. Most developers don't want to find the problems because it's opening up a can of worms for them, really. But that makes very interesting research, and ultimately it saves some life. So in summary, most of the data is published where we can publish it, or it is shared. Unfortunately, some of it isn't. Anything, John? I hope that answers your question.
All right. I'll just add in here, one of the problems that we have in Canada, very similarly to that, is that we don't have a consistent system for benchmarking the performance of buildings, with the result that we're really not comparing apples and apples. We don't really have a means of doing that. And that's one of the things as we move forward that we really need to address, a common system of comparing building performance. Are there other questions? Oh, Trevor. I love this, actually, raising your hand thing.
Hi. I didn't see if that worked, but I do have some results working. If I could show you those, would that be of any interest?
Yes, that would be great. But let's do that. But let's just see if there's any other questions for the Cardiff people, and then we'll move back to to look at Matchbox again. So, any other questions for Cardiff? Bobby?
So you collect the data, and now I know where it goes. Is there any initiatives to get it to like the everyday user to help educate them, and then I guess home renovation here in North America is huge, and if there was easy ways to make things more efficient and better, is there any initiatives out there to educate the sort of average person on how to do this affordably and stuff?
In terms of the findings from the BPE study, it had about 13 mandatory categories, and one of them was engagement with occupants in each of the case studies as a series of interviews. And as and when we were finding monitoring data, we were presenting to occupants, we were presenting to the design team, to the contractors, and also to the local government. In terms of sort of empowering occupants, many of the housing developers in Wales focusing on social housing often have something called energy champions, whereby, so for example, in this particular project where we monitored, one of the occupants from the housing estate was passing on the information to other occupants, and they were having monthly workshops, sort of coffee mornings, to discuss the findings.
Oh, great.
Yeah. Okay. Thanks. Hope that helps.
Yeah.
All right. Any other questions for Cardiff? All right, Trevor, if you want to grab the screen, if you can do that, that would be great.
Can people see my screen? Can you see it? Okay. So this is I've just found a different building, and I know this one works So when we calculate the results, we can just run through what you might expect. So I'm going to make the results go onto a full screen page. So we have net energy use numbers here, and our total net energy per year. These are annual numbers. So this many kilowatt hours. And it gives us a month. We have a monthly breakdown, and a breakdown into fans and pumps, domestic hot water, outdoor air, fabric energy, cooling energy, plug energy, and lighting energy. And we can sort of track where the main energy is consumed. So it's common with a good building envelope to have much higher much higher of the proportion is on hot water and on appliances, plug loading. You can see the actual skin losses to do with the building envelope are over here, which is about probably a third or a quarter of the overall annual energy. So it's become much more focused on how do we manage the internal loads rather than the external loads. This is where there's a much higher building regulation standard. The difference between gross energy and net energy. Gross is the actual demand of thermal and electrical power that's needed, and the net energy is really how that's delivered. And a heat pump has a much greater efficiency than just the electrical resistance heaters. That's the difference between gross and net. But again, it breaks it down into different loads just here. We can look at peak loads, and for each month there are kind of 3 daily snapshots within each month, 8 a.m., midday, and 4 p.m. And you can see how these change through the year. Solar gains as well, based on different elevations, different types of glazing that we have. We can see where the main culprits are or benefits are on getting solar gain. And then these are the skin losses, which break it down by surface, by floor, by roof, by wall, by glazing. And you can see here on the yellow zone, for example, the floor is contributing massively to the heat loss. It wasn't a very well insulated floor, but the roof, which is this blue zone, is also kind of in second place, which is what you would expect. Ventilation loads, these vary from a heating perspective and a cooling perspective. So in the middle of, this is Johannesburg, remember, so we have a main heating demand in the summer, and then the heating demand in the middle of the year, and then in the over January, December, it's much hotter time of year, so there's more cooling. And then casual gains really are made up of the plug loads, the lighting, and the people loads. So if we're just going to go back to this and just say let's go to Mexico and go to say Monterrey, we can just see how the loads vary. And so you can see that the net energy altered slightly. The peak loads varied quite a bit from before. And you can just go through different, countries and cities, compare Cardiff, say, with Mexico. And here you can see how the energy intensity would vary. In Canada, we're going to go right up north to say Yellowknife, which is in Northwest Territories, and we'll see that this should change, a lot more. That's what I wanted to show you before, and I'd say that if I'm sorry that we didn't get it working first time. I just wanted to show you what it can do. If you do have problems, then I can get them sorted out pretty quickly. So just let me know if you have any of those errors that come up, and we can make adjustments pretty easily.
Thank you so much, Trevor. I have to say to the students that, wow, this gives us a level of analysis of your building designs, which really we've never had before. Yes, as the Cardiff people pointed out, there are other systems available to do some of this, but they are very difficult to use. We've been sort of hoping for something like this for some time, and the fact that Trevor and Richard are sharing it with us is really it's really wonderful. And when I saw that thing you just did there, where you switched between Monterey and Yellowknife, and how quick it was able to reanalyze the thing, for me, that's the promise and the opportunity of what we could do here. So I hope everybody will find time to sort of put their designs into it, and that we could start to see some of this. Are there any questions for Trevor before we let him go? All right. But thank you again, Trevor, and thank you. Please say thank you to Richard as well for letting us use the software. Now, I'm going to see. Leaving conference. Was Daniel able to dial in with us?
No, unfortunately, he wasn't.
Okay. All right. So I guess today we might even make if we can figure this out. We have been having problems with South Africa, and of course they are having problems at their university as well. We'll work behind the scenes to see if there's anything we might be able to do. Do you think, Kristen, there's any point in well, if we all, I think we'll just try and set up a separate session for Daniel. Any other comments on that one, Kristen?
That's what he suggested as well.
Okay, we'll try and figure something out for everybody and make that happen. So at that point, and it is too bad we can't have Daniel online, but I'm going to move to Kristen, who's going to talk a little bit about the social media software that we're suggesting that the students use for this. So, Kristen, I'll hand it over to you.
Okay. Thank you, Douglas, and hello, everyone. Many people argue that the whole discussion about the Earth's sustainability began in earnest with her first photograph from space, which was taken in 1972 from the Apollo 17. Today, sustainability has become one of the hottest and yet one of the most ambiguous terms. Addressing that ambiguity are such projects as this one that we're working with, and the Matchbox software, which is rooted in hard science, unlike a lot of the sort of nebulous responses to sustainability. And our ability to share with our designs and our contexts from around the world, which is rooted in human experience. And so we're hoping that Trello can be the vehicle for which we can engage with each other over these projects and over the places in which we do design, and we can begin to build the international community that Douglas spoke of in the beginning. So I'm going to discuss a brief overview, which will include the basic board, the cards and lists, and how to edit those cards and lists. So what you see here in front of you is the basic board, and here are lists. And so there's a list for each of the different groups that are participating, and then we have a references and links, and a general project information. And we, in order to join, and use this platform, this website's been made available to all the group leaders. And there's no cost, but you do have to actually, each individual join. Okay, some of the attributes here, you'll see I've set up some of the initial cards for today's meeting, for example, right here. And a couple of things to point out. First is this little green bar here, which is a label. And you can see that what it allows me to do is put a label here on this card and a label on this card down here and a label over here. So that what I'm telling you by doing that is that all of these things are related. So here we have the meeting phone numbers. Here we have the dates and times of the meetings. And here we have the card that's going to describe the first meeting. Okay, so, and then the lists themselves are basically where the cards are organized. And then the cards are where we put the information. And here you'll see this is a card. So each of these individual white blocks with a title on it is a card. Now, in order to, on each list, you can add a card. And in order to do that, you will hit, you can see here the add a card, and then this will come up. Then you'll type in the title of your card, and you'll hit add. If you decide you don't want to add that card, then you can hit this X, and it will be removed. So there are a couple of different ways to be able to edit the cards once you've created it. Here you can see that I have that this is the title of the card here, and then on the card, when you run your cursor over it, a little pencil icon will come up in the right corner. And if you click on that pencil icon, these are the options that you're going to be able to access. Probably the primary one you'll use is this edit labels as a way to organize the different cards. We're all going to remain as members, and really there isn't a reason for some of these other options here, but they're there if you want to use them. And then whatever you do here, you need to hit the save button so that your changes are saved. Okay, and then the primary description of the card, if you click on the card itself, so just anywhere on the white card, this is the box that will come up. And what this box allows you to do is type in the primary description of the card. So in other words, this is the meeting phone numbers and links card. And so I've typed in, all the different phone numbers, what the code is, and what the Adobe Connect link is. And then I've given it a label, which is just this green bar, in order to, as I said before, to show that it's related with the meetings. Now, what someone else can come along and do is they can click on the card, and then they can add a comment. So say you have a question or you want to comment on the fact that you were unable to get through, you can put that comment here and you can hit the send button. You have various different options with this comment box. You can either add an image, you can send it to somebody, you can add icons to it, and then once you've made your changes, you hit send, and it will come up listed on this in a way similar to what many of you may be familiar with on Facebook on the timeline. Okay, then additionally, there are these options over here, which are for again to add different attributes to the card. This probably the primary one you'll be using would be this attachment here, and what that allows you to do is add images. When we go back to the original image, which we'll see again in a minute, you'll see that I've put in some images on the cards. So you have two different options. You can either add an image within a comment, but if you want an image to stay with the original description of the card, then you add that image here with the attachment, as opposed to down here with a paperclip. So these are the images that I'm referring to. These are the images that will show on the card itself when it's sitting on the board. If you just add comments, those will not be visible, or images within a comment, those won't be visible until you actually click on the card. So that's the difference with adding images there. Okay, so this has been, I know, a very brief overview, but I think any one of these lists and all of the information within.
Kristen, you might want to repeat. There was just a whole bunch of sirens someplace that sort of came through.
What I was saying is that you begin to see how the interaction can take place, because when you come on, you'll be able to access the cards from all the other groups. So you have these two general information here, and then you have each of the groups will have their own cards to be able to add their projects, and then you'll be able to look at other groups' projects. Now, to get some further information about how to use the Trello and sort of troubleshoot, you can see up here where I've highlighted this information icon up here. If you click on that, then you'll need to click on More and then click on Help. And then you'll be able to type in questions that you have. And there's actually a very good help service with Trello Online. And with that, if anybody has sort of any further questions about this initial overview, and thank you very much.
Thank you, Kristen. I'll just also mention that we use this Trello software in our virtual design studios, which many of our students who are online today participate in. And it really depends on people making contributions. So I would encourage everybody, if you've got something that the group might be interested in, I would encourage you to post it and share it. Certainly all of us, I hope all of the different professors involved will be posting things to this site. And it really does, becomes a resource that people can often find surprising things that they might not have thought about before. So thank you very much, Kristen, and we'll see if anybody has any questions. Anybody? Okay. Please, I highly recommend that you go to the site, log in, and as Kristen mentioned, it is free. We'd like everybody, faculty and students, to all join and make contributions, and I think you'll find it very interesting. And of course, we can even keep this one going after the pilot project.
And if anybody wants to contact me, that's fine as well. If you have trouble getting on or with any questions about Trello, I'd be glad to help.
Okay. Thank you, Kristen. And that is one of the things, this is our first meeting, and in many respects it went extremely well. We've still got a couple of things that we want to tweak, and we certainly want to get South Africa connected. So we'll be working on some of those things. But if you do have a problem of any kind that you want to address to us, one of the best ways is to send Emma an email. That seems to be not a bad way. And Emma, I'm going to ask you, if you don't mind, to in the chat area, just to put your email address in there, so that if you had a problem today, whether you couldn't hear or your video was causing problems or there's something else that you want to address, send it to Emma, and then we can try and deal with it before we meet again. And I'm going to leave some time for questions, though, just in case we start to lose anybody. Our next meeting, I think we've all agreed, is Monday, October the 24th. And at that meeting, instead of us all talking, it'll be the students presenting their work, and we'll sort of get all that organized behind the scenes. So for those students online, we're hoping for just a very brief 5-minute overview of what you're working on and give you another 5 minutes for as time to get some feedback from all the experts that we have online. So that's Monday, October 24th. The final meeting would be Thursday, November 17th, and at that one, we'll look again at student work, and hopefully it'll be more refined and more final in its versions. And again, we'll have time for presentations and experts to comment on it. So I'm hoping everybody will find this very valuable. Let's keep to the same time, as it seems to be about the only time that sort of works right across the different cities and areas and regions that we're connecting. And it quite frankly, you know, with all the things that could have gone wrong this morning, this afternoon, this evening, I'm very glad that we were able to connect and do all these things. But the other thing, just before I open up to general questions and discussion, is that I did circulate a press release. We are going to be posting it probably even later today on the Athabasca website and sending it out to various kinds of media in Canada. If you'd like to use it, please go ahead. If you see anything in it, though, that you'd like to change or add to, feel free to do that as well. I'll be sending out I've got to talk to the media person just as soon as we're done here. Then I'll send out another version if she wants major changes, and we'll share it with you. But I can't tell you how happy I am that this has finally come to fruition after all of our discussions and all of our tests and things like that. It is a delight when we can make some of these things happen. So I wanted to thank everybody, but I wanted to thank Emma and Kristen in particular, because behind the scenes they've been pushing and making all of this happen. I will remind everybody there's just one thing. Again, all of this is just, you know, it's a very simple system, but one thing that the funding organization, which is the Alberta Government of Canada, has asked is that students and professors fill out a questionnaire at the end of this whole kind of project. So we do have those surveys, those questionnaires, and Emma will be sending them out to everybody. And we'd really appreciate it if you, at the end of the whole, after November the 17th, if you fill them out and send them back. So again, if things that people would like to add or any questions that they have, now is a great time to do it, because I think we're doing very well in terms of time. So either everybody's connection has gone dead, or there's no questions, or we've been online for, I guess, about an hour and a half or more now. So one last time, does anybody want to make any comments?
No.
Yes, please.
Matthias back here. I was just kind of curious if, I guess, like, I'm not on the highest level of my REIT courses, but I was just kind of curious what kind of projects other people were working on. Like, is there any kind of, like, clarification? Does anyone know, like, if someone could, like, let everyone know kind of, like, what projects they would be working on? Or, because, like, I think I'd be working on some, like, smaller scale homes, but nothing too strenuous here.
Okay, so the question was, what other kinds of projects students will be working on?
Yeah, correct.
Okay. I think Eduardo showed the kinds of projects which the project 1 and 2 that they'll be working on in terms of both the housing and the apartment units. So what about maybe could the Cardiff people share the kind of projects that their students will be working on?
Mostly I think we're going to be working on office buildings, 2 3-story office buildings, not particularly large, high-tech companies. I'm trying to remember the kind of rough floor area, around about 1,000 square meters in total, something like that. As I said, we've actually got models which some have already constructed on a site to the north of Cardiff, and we've been looking to optimize those designs using the Matchbox software. So commercial buildings for us.
Okay. And then in terms of the Canadian context, to share with everybody, we're offering the opportunity for students in any of our virtual studios to participate in this project, and in order to enhance their designs by looking at them and really analyzing them in terms of their energy. So this means that we might have anything from a single family house up until multiple housing units to institutional buildings as well. And my hope is that no matter what studio you're in, that you would benefit from those kinds of designs. And I'm just trying to remember in South Africa. Oh, Kristen, do you remember what Joseph is working on?
Yes, I was just going to say, it sounds quite similar actually, so which will make it interesting to the students in Cardiff, because it sounded, if I remember correctly, like they were doing also work on optimizing existing buildings as opposed to designing new buildings. So hopefully that'll be an interesting, there'll be some interesting dialogue back and forth between Cardiff and Johannesburg.
Excellent. Thank you, Kristen. And Bobby has just added in the chat area that he's working on the design of complex buildings, places of assembly, and institutions project, in particular a secondary school, which is a high school for the arts. So I think there'll be a range of projects, and I think that's probably good. Not only do we have a range of projects, we certainly have a range of different climate zones and geographies. So it'll be very interesting to see and compare how students deal with the challenges that they're facing. I also like the fact that we've kind of got an interdisciplinary approach with electrical engineers in Monterey and architectural technologists in Cardiff. And so this gives us a kind of a broad sweep of what's happening in the world. And I think that'll be useful as well. Does that answer your question?
Okay, perfect. Yeah, I was just kind of curious to see what everyone was doing, especially since we're like all around the world. It was just kind of cool. Yeah, thank you.
Could just quickly add, I think Daniel and his group will be quite an interesting addition as well, because one of the things Daniel's most interested in is sort of looking at this from sort of energy use from cradle to grave, and both within the buildings and the materials, particularly because in Africa the mining of materials can have a huge both environmental and human cost. So that's one of the things that I'm sorry he wasn't able to talk today, because that's one of the things I find particularly interesting about his approach.
All right. Any other questions? All right. I really appreciate everybody's patience today and everybody's participation today. I think I'm hoping that this will be the start of us building international relationships that will continue long after the life of this project. But this is a very good start to what we want to do, and I'm really looking forward to what the students are going to show us when we get together again in October. So again, check the press release. Be prepared. I'm going to be sending out the questionnaires. And if you had any problems today that you'd like to try or just improve your connection, send them to Emma. We will certainly be working with Daniel and the people in South Africa to figure out a way to get them connected. But thank you to all, and I really appreciate everybody's participation. It really is really gratifying to see all this, all of us connected now. So thank you very much.
Thank you.
Douglas, I'm just going to quickly put the link for Trello. I'm just putting it right here on the chat.
Okay, yes.
Be able to copy.
Leaving conference.
All right.
Christopher.
Oh, and it looks like, Eduardo, you have a question. Sorry.
Yes, when we will have the recording
Leaving conference
available?
Bobby Harris.
Okay, I'm sorry, Eduardo. Somebody was signing out, so I couldn't hear.
Oh yes, the recording of this session. When it will be available?
That's a very good question. Emma, what do you think?
I can have it sent out later today.
Okay, that's Emma. So later today, which would be wonderful.
Thank you.
And we'll probably try and post these kinds of things to Trello as much as possible, because we would like to generate some traffic there. But we'll see what we can do to make sure everybody gets connected to it. Okay?
Okay. Perfect. Thank you.
All right. If there's no further questions, I'm going to let everybody go, and thank you again for your participation today.